Happy Tuesday, 8th grade. So we're looking at lesson 13 for math, which is actually the last lesson of our unit. So tomorrow, Wednesday, you will have a test for math. So lesson 13 is the comparison of numbers written in scientific notation and interpreting scientific notation using technology. So let's go. So the Fornax dwarf galaxy, 4.6 times 10 to the 5th light years away from Earth, while Andromeda 1 is 2.430 times 10 to the 6th light years away from Earth. We want to find out which is closer. So first, the easiest way to compare numbers written in scientific notation is to write them with the same exponent, or the 10 to the power, because then it's way easier to compare them. So Fornax dwarf isn't going to change, but Andromeda is going to change. So we'll write it as 24.30 times 10 to the 5th. So you could write it as 2.430 times 10 to the 5th times 10 and then write this way, but this would be the fastest way to get there. So then we compare the two numbers, so 4.6 and 24.3. We know that 4.6 is a lot smaller than 24.3. So we know that FD, or Fornax dwarf, is smaller, so then it is closer to Earth. So let's look at this one. The average lifetime of the tau lepton is 2.906 times 10 to the negative 13 seconds. And the average lifetime of the neutral pion is 8.6 times 10 to the 17th seconds, which has a longer average lifetime. Sorry, that should have a question mark at the end. So again, first we want to put them in the same exponents. So the neutral pion is not going to change. The tau lepton we have first written out normal. Then we're going to write 2.906 times 10 to the 4th times 10 to the negative 17th. So again, like I said before, you could write that extra step, but then we write 29,060 times 10 to the 17th is how we would have to write it. So we know that 8.4 is smaller than 29,060, which means 8.4 times 10 to the negative 16th is smaller than 29,060 times 10 to the negative 17th, which means that 8.4 times 10 to the negative 17th is smaller than 2.906 times 10 to the negative 13th. So a tau lepton has a longer average lifetime. Okay? So now you're going to work on these two by yourself. Go ahead and hit play when you're ready to see the answers. Make sure you correctly read the second question here. So the first one, we have compare 9.3 times 10 to the 28th and 9.2879 times 10 to the 28th. So like we said, the first step is to have them have the same exponent, which they already do. And then we only need to compare those first numbers. 9.3 is greater than 9.2879, therefore 9.3 times 10 to the 28th is greater than 9.2879 times 10 to the 28th. And then the second one, Chris said that 5.3 times 10 to the 41st is smaller than 5.301 times 10 to the 41st because 5.3 has fewer digits. Although he is correct, his reasoning is not. Show how the answer is correct. So if we would add two zeros to make them have the same number of digits, 5.300 is still going to be smaller because 0.001 is more than 0.000. But not always will the number of digits work to a correct answer, because when we look at numbers in the thousandths, they have the same number of digits, but that doesn't mean they're equal. But all decimals are a big thing. So if we had 5.30479 and 5.304, one has less digits, but it's smaller. But we could just say 5.4 or 5.5, and that's going to have more digits, or less digits, but it's still going to be the bigger number. So we have to be careful that we're comparing the numbers rather than just the amount of digits. Okay, so next we are going to look at lesson 13 and modal questions for your assignment. Like I said, tomorrow you're going to have a test, so we'll review before we do that, but if you have any questions on the assignment or don't understand something about this lesson, please let me know. Otherwise, have a happy Tuesday.